Can technology help us solve the challenges of climate change? Robin Lindsey from the University of British Columbia in Canada will give us a clearer picture.
Hello, my name is Robin Lindsey and I'm a professor of transportation economics at the University of British Columbia in Canada. And the topic of my presentation is climate engineering, and I'll describe what that means during the presentation. And this is part of a consortium called Action and Inaction in Climate Change, based at Cergy University in Paris. It's a fairly recently formed consortium, and it has a lot of work to do. So my presentation has 4 parts as indicated here. First is the introduction, and I'll talk about the climate emergency, which probably everyone has heard about. It's a real concern about the future of living on planet Earth. Then I'll talk very briefly about the existing policies which are insufficient to deal with climate change, to stop the rise in temperatures and the other manifestations of climate change. Then I'll indicate what climate engineering is about. And essentially, it's what's described in the second and third parts of the presentation. One set of tools for addressing climate change involves removing carbon dioxide from the atmosphere or not emitting the carbon dioxide in the first place. And then the other type of technology involves what's called solar radiation management. And the intention there is to have less heating from the sun by either reflecting the incoming solar radiation or enhancing the radiation during night. And then finally, and again briefly, I'll talk about the challenges and the dangers of climate engineering, which should not be minimized. Now, the presentation, of course, has to exclude a lot of things, and what I will leave out are a discussion of alternative energy sources, alternative to the coal, the oil, and the natural gas, which are still the main basis of energy in today's society. So I'll be neglecting existing technologies which are well established, such as nuclear fission, eliminating or avoiding, not discussing emerging technologies, some of which are established, but something like tidal power is rather difficult to implement. There are only a few places on Earth. Right? So even if that technology is implemented as much as it can be, it falls far short of what's needed to deal with climate change. And then we have technologies which are being studied for quite some time, particularly nuclear fusion, but that's an extremely difficult technology. It holds great promise, but it'll be some years before it's implemented. So the climate emergency, I think, is most apparent from the change in temperature that we've experienced in the last few decades. And this is attributed in large part to the increase in the concentration of carbon dioxide. Before the Industrial Revolution, that is in the late 18th century, the concentration is estimated to be in about 280 parts per million, which sounds not very much, but carbon dioxide is a highly potent greenhouse gas. Right, so one molecule essentially creates a lot of heating. And then the latest figures, which come from earlier this year, indicate that the concentration has risen to 424 parts per million, which is just over 50% of the level, 50% increase in the level from the pre-industrial times. And then in parallel, the mean global temperature has risen by about 1.1 degrees centigrade. And we can see the rate of increase in the concentration of carbon dioxide as well as the temperature in the 2 graphs. The one on the left records measurements done in Hawaii of the concentration of CO2. And that graph begins just before 1960. And you can see that the concentration then was below 320 parts per million. So some 70% of the increase in concentration of CO2 has occurred in the last 60 years. And the graph is increasing to the right at an increasing rate, which says not only that the concentration has been rising, but it's been rising at an increasing rate, which is highly alarming. The graph on the right starts back in 1880, and that shows the average global temperature relative to the mean value in the mid-20th century. And the blue sections below the horizontal line indicates that the temperature on average was below the mid-20th century average. And then to the right, the orange indicates that it was above it. So you can see with a few exceptions towards the middle of the graph, the temperature was growing and growing at an increasing rate. All right, so there's clearly a strong correlation between the concentration of CO2 on the left and the rate of increase in the temperature on the right. So how long have people known about the greenhouse gas effect? Well, the answer is they've known it for a long time, and they've known that carbon dioxide, in addition to water vapor, is the main greenhouse gas and is responsible for the climate change. The Swedish physicist Svante Arrhenius recognized that in a publication in the late 19th century. There are a few skeptics, but most people, and I think just about all scientists, accept that it's people who are responsible for the increase in temperature and the other signs of climate change, increase in the level of the sea, which of course poses a threat to a lot of low-lying and large cities. It doesn't take much of an increase in terms of tens of centimeters for there to be a real threat of severe flooding and even damage which destroys buildings. And there's also an increase in the acidification of the ocean, and that's because of the absorption of carbon dioxide. And that so far has mainly been on the surface, but it has had adverse effects on coral reefs. So it's people who are responsible for the climate change, and hence, if you want to stop it, reduce it, action has to be taken. And the time available to do that is fairly short. Back in 2015, not many years ago, the Paris Climate Agreement set 2 degrees centigrade increase as sort of a hard goal, very much desirable to limit the temperature increase to 2 degrees and preferably to 1.5 degrees centigrade. Well, we're already at 1.1 degrees centigrade and the temperature is increasing rapidly as we saw in the figure. Moreover, the El Nino southern oscillation is forecast to start shortly, and that'll cause a more rapid increase in the temperature. So within just 5 years, we could at least briefly experience an increase on the average global temperature of 1.5 degrees centigrade. And I might note that the average is not all you should think about. Along with climate change, there tends to be more extremes. So there may be periods of unusually cold weather, but also extreme heat. And that's been experienced in recent years, including where I live, where the temperature went to nearly 50 degrees centigrade. And that's a northern latitude. And people died, and there were real problems for the economy. So this is a problem, an emergency in the sense that we're not talking about century sense where the problems will occur. They're occurring now, and they're occurring more rapidly. So will dealing with the climate emergency be easy? The answer is no, it will not, for various reasons. One reason is that carbon-based fuels, coal, oil, and natural gas, and also ingredients into some chemicals, still account for more than 4/5 of the primary energy supply. And so we're still relying very heavily on carbon-based fuels. Transportation is responsible for about 1/5 of the carbon emissions, and I single that out because it's the sector of the economy which will be most difficult to move away from carbon-based fuels. And it's partly because cars don't have a lot of capacity. Electric vehicles are coming in, but they're limited by the availability of rare metals and so on. Range anxiety is still a problem, etc. Substitute energy sources can be found, but they're either going to be more costly or they have to be developed further before they're practical for use. And also, even if you have a ready available alternative energy source, capacity constraints limit the rate at which they can be brought in. And there can also be regulations which have to be satisfied, particularly for newer technologies, because they have unknown side effects. And then there can be local opposition, for example, to wind power, because the huge windmills, they make noise, they obscure the vision, and so on. And the NIMBY, not in my backyard, can cause delays in implementing those technologies. Wind and solar have made great advances in the last 15 years. The cost, I think, per kilowatt hour has dropped by about 90%, but still those two sources are intermittent. The wind doesn't blow all the time. And the solar power, of course, is only available during the day and when there's no substantial cloud cover. So if you want to rely on just those two sources of energy, you need a means of storing them when the wind isn't blowing and when the sun isn't shining, and that will require batteries or pump storage, and of course that's quite costly to put in place. Solar energy also has a relatively low power output per unit area, so you don't get too many watts per square meter. So if you want to get a large fraction of your power from solar energy, solar power, you need to devote a lot of area to that, and in cities that area may be unavailable. Hydrogen is another technology which shows promise. It's green, but it doesn't come naturally. It has to be created with using some form of energy. And then to be used, particularly in transportation, it has to be distributed. And so far, the infrastructure for that is rather limited. And then some mobile plant cars and drones now, they can run off batteries, but not yet hydrogen. So there's various technologies which have to be further developed before hydrogen can become an important component of the energy mix. Now, in order to implement policies, government intervention is arguably necessary. Right? People may be willing to go some way towards conservation, which would involve, let's say, reducing the thermostat in the winter so the house isn't quite so warm, and raising the thermostat during the summer, and then using their car less frequently, or when they buy a vehicle, a smaller vehicle with a less powerful engine, which uses less fuel. But the typical person incurs inconvenience and increased costs from that. So it's argued that a government, whether it's at the EU level or the federal level or the provincial or the state level, will be needed. And we know that government intervention is usually resisted. We had the demonstrations in France 5 years ago about a modest increase in the price of fuel. Economists like me argue that the carbon tax is a good instrument because it can be broad-based, it can be applied to all uses of carbon and so on. But we know that carbon taxes, which would be implemented for transportation through fuels, are not popular at all. And indeed, only 23% of global emissions are covered yet by carbon pricing or the quantity equivalent of that, which is a cap and trade scheme. So less than a quarter. Now that fraction is increasing, but there are probably some countries, perhaps the United States, which aren't going to implement it for some time, if ever. Also, conventional means of combating climate change are rather limited. That therefore brings us to technology-based methods, that is to climate engineering. Now how does climate engineering fit into the big picture? Well, it involves mitigating the effects of climate change. So the climate change will proceed, but you can reduce its effects through various mitigation methods, and I'll show you about a dozen. And it should be distinguished from what's called adaptation, which involves responding to climate change, whether it's increased temperatures or a rise in sea level and so on. And that can be done in various ways. Seaports would strengthen the seawalls, right, so they can withstand storms for another few decades. It can involve relocating activities, agriculture, for example, or changing the activities which take place at a given location. So you have one crop which has been grown for centuries, but as it heats up and maybe you get more or less rain, it's no longer viable. Well, if you want to continue to use that plot of land for agriculture, then you may have to grow a new crop, and that can be an imposition on farmers, although they may well be more than willing to do so. So what types of climate engineering technologies exist? Well, it can be divided into two categories. One, carbon dioxide removal, or if you like, carbon capture, which involves either not emitting so much carbon or possibly removing it from the atmosphere, and then the solar radiation management. And these two categories are quite different, and I'm going to cover them in one and then the other. And indeed, the Intergovernmental Panel on Climate Change, which has been operating internationally for since the 1980s, no longer uses the term climate engineering, partly because of the disparity in the methods which are included. However, for ease of presentation, I will use the term climate engineering here. So apologize to the IPCC. So as I've indicated, scientists have known about climate change for quite some time, and they've also been aware of the possibility of climate engineering for many decades. And in fact, John von Neumann, the famous mathematician who developed game theory and made some other seminal contributions to physics and so on, discussed the possibility of what he called climate control back in 1955, so nearly 70 years ago. And he talked about the possibility of increasing the reflectivity or the albedo of the Earth's surface, right? So less of the energy comes and heats the surface. But he was also very much aware of the difficulty of climate control. Now, nearly 70 years on, of course, the technology has advanced greatly, but we're still very much aware of the challenges, and in some ways more so than he was, because so much more has been learned about the physics and so on of the planet. And there, of course, have been many other studies of climate engineering more recently. The IPCC has done a number of studies, as well as institutions in the United States, the United Kingdom, and elsewhere in the world. Now, climate engineering is a highly risky, and if it's implemented, it'll be very costly, but because of the severity of the climate crisis and the inability of existing methods to adequately deal with it, most experts now argue that some research should be put into climate engineering. Now, some has been already, but perhaps that funding should be accelerated. And you can think of that as a form of insurance. Maybe some of the more esoteric technologies, such as the ones that I'll mention towards the end of my presentation, will never be implemented. Still, you want to have them advanced so that if they become necessary, they can be deployed in, let's say, 5 or 10 years rather than 25 years. Because if it takes so long, the climate change is going to continue and the adverse effects will be multiplied. So think of it as a form of insurance. And that's the end of part 1.